So here we said that this network is what deals with generation, transmission, distribution, and utilization of electrical power and electrical devices connected to the system, including generators, motors, transformers, and others, electronic usage, and others. So, of course, this is a diagram from the Saudi Electricity Company, which is the national electricity company here. It simply shows you that you have a generation station, which we call a power plant. The generation station operates at 13.8 kilovolts and starts to output up to the point where the step-up transformer is located. This is called a substation, where we increase the voltage for transmission to 132 kilovolts or 380 kilovolts, depending on the distance. All right, then in this orange part, which is your overhead line or cables, it reaches up to this transformer here, and this is where the electrical current is distributed to various areas. This is the distribution transformer that steps down the voltage again from high or extra high voltage to medium voltage. From medium voltage, it starts distributing, including in your neighborhood where there is a distribution transformer within the neighborhood with a ring main unit. Through this, the voltage is reduced to 400 to 230, and it begins to distribute to your loads. As you can see here, this line up to this point is the power generation stage. After that, until it reaches this distribution transformer, it is the power transmission stage. And finally, this part is the distribution station. Regarding the Saudi Electricity Company that we will study here, Saudi Arabia was initially divided into 3 completely separate parts. Each was separate, meaning you had the western region, the eastern region, and the central region. Each one of them generated its own electricity and adjusted the voltage as it desired. All right, very good. So you had the 3 regions, and they all had a range of 13.8 kilovolts. All 3 had this range, which is the range of 13 and 18 kilovolts, all right? And all 3 had a range of 33 kilovolts. Of course, you might ask, what about the 4th one? I'll tell you, it's the southern region. Nice, but if you then noticed, they had the idea that when you go to high voltage to transfer within the country, within the same region, from Riyadh to Dawadmi or elsewhere, they would raise it to high voltage in Riyadh at 132 kilovolts. In the western region, it was raised to 110 kilovolts. In the eastern region, it was raised to 115 kilovolts. And in the southern region, similar to the central region. When we started connecting these regions together, you had 2 things. Firstly, the distances between them were already far over 300 or 350 kilometers. So you needed to raise the voltage even more to reduce the current, thereby reducing losses and voltage drop. The second thing is that the voltages they had were different. So you couldn't just connect these voltages together without causing a short circuit. That's why we all moved to raising the voltage to the ultra high voltage level, which is 380 kilovolts or extra high voltage, 380 kilovolts in the 3 regions to connect the regions together. Of course, in the eastern region, you will find 2 other levels of voltage that are not extended in any other region, which are 69 and 230 kilovolts. Of course, that's nice. Now, this is the shape of the low voltage panel, engineers. And this is, of course, the distribution board that is present. If any of you work at a university, if any of you work in a mall, if any of you work in any commercial sector, or if any of you work inside a power station, you will always see this panel, whether it is a distribution board in all loads and inside power stations. They also call it the AC distribution board, but they say it's an auxiliary system, just to clarify for the young engineers who might get confused. There were several questions about this part. The AC distribution board, engineers, as the name suggests, is for AC, which is alternating current, meaning the distribution board for AC. If you are in a mall, you use it for lighting and things like that in the mall. All right, if you are, sir, in a commercial building, it's the same thing. Inside the power station, it's also the same. But inside the power station, it's called an auxiliary system because it's used to serve the subsidiary loads of the station. However, in the mall, it's primarily used to supply the main loads in the mall, such as lighting, air conditioning, and others. The idea of an auxiliary system, no one says this is an auxiliary system. No, here in the electrical stations, it is called an auxiliary system as a function of providing. But first and foremost, its name is AC distribution bolt. And what is this? Low bolt is a group of first things in which there is a group of cameras on a circuit breaker, and then the distribution is through either a molded case circuit breaker or a miniature circuit breaker. The circuit breaker is either a molded case circuit breaker or a miniature circuit breaker. Then we have the medium voltage switchgear, the high voltage switchgear, which is of course the gas insulated switchgear type. And we also have the extra high voltage switchgear, which is also GIS. Okay, now engineer, I want to get into my power station and start looking at the bus bar. What will you tell me about? I'll talk to you about medium voltage switchgear. So what does medium voltage switchgear mean? Medium voltage switchgear. Engineers is what I'm talking to you about, the bus bar. This bus bar is the 13 sections. I'm talking to you about the bus bar, meaning this whole course is based on this bus bar. So what's the story, engineer? What do you want to tell me? Quite simply, what does this bus bar look like? The connection you have at home, you plug in a socket and 4 outlets come out of it, right? Or am I wrong? Right, very good. Now, let's say you have 4 plugs in your power strip or in your connection. One of the devices has a fault. One of the devices has a fault. In this case, what will happen? You'll find that the entire power strip or connection is off, right? Meaning one of them has a fault that shorted the rest, correct? Now imagine that these parts are like a 3-pin plug, which includes the safety and grounding pin. Imagine you brought a device from Egypt that only has 2 pins without the 3rd pin. You want to plug it in, but you need something to bypass the safety pin to insert the plug. Now, regarding the design, I'm talking about the design. How is the design created? Well, there are problems and challenges you face, of course. So what design should you take? What should you consider? Let's see together what he said. He mentioned the first thing is that when you choose a specific bus bar in a certain way, the first thing you look at are these 5 points. The first is simplicity and the system, ensuring that the system is simple. The second thing is easy maintenance of different equipment. It should be easy for you to maintain the various equipment inside the switchgear. This distinguishes the outgoing gear from the internet, like the example I'm telling you about now. If one of them fails and you need to perform maintenance, if you come to maintain this socket, all the other sockets are connected from the same connection. If you come to this socket and want to connect or do something, you might get electrocuted. So you're forced to disconnect the supply from all of them. Therefore, you need to think of a way to minimize the outage during maintenance, meaning you reduce the outage or reduce the disconnection of other loads during maintenance operations. You start, Mr. Rashad, you will explain to us. Of course, we will explain in detail. But I gave you a very simple example that you all know. You know your connection might have an on or off switch next to each socket, but of course it is wrong. You have improved the performance of the connection by being able to disconnect this socket alone, meaning it can go out of service with you, and you can perform maintenance on it. Future provision of extension with growth of demand. What does this mean? It means that if you come in the future and want to imagine bringing a socket with a connection with 4 sockets only. So if you brought 2 more devices, where would you connect them? Yes. This means it won't provide you or grant you the ability to expand further. Right, am I wrong? Very good. So what's the solution? What should I get? Here, there are solutions regarding the passport, but I'm not talking about the connection regarding the passport. Passport, right? Optimizing the selection of bus arrangement scheme so that it gives the maximum return from the system. Let's see how we can use this. I said, let's look at the different bus arrangements. Of course, here you have several types of bus bars. I will lay them all out for you, but I won't tell you, not just in the medium voltage bus bar that I have.